Hi students, today I would like to discuss about polarization. So presentation layout, introduction, types of polarization, Nicol's Prism, production and detection of polarization, engineering applications of polarization. Introduction. The phenomena of interference and diffraction. So diffraction means the bending of light waves around the edges of an obstacle is called diffraction. Interference is the modification of intensity due to superposition of two or more waves is called interference. The phenomena of interference and diffraction established the wave nature of light, but the properties do not tell us whether they are longitudinal or transverse. The phenomena of polarization reveals the fact that the light waves are transverse waves. In transverse waves, the wave propagation is perpendicular to the wave propagation. The polarization, transforming unpolarized light into polarized light, a restriction of electric field vector E in the particular plane so that vibration occur in the single plane, characteristic of transverse wave. Longitudinal waves cannot be polarized. The direction of their oscillation is along the direction of propagation. Polarization. The light which has acquired the property of one-sidedness is called polarized light. So what is the polarizer? What is the analyzer? The vibration of light coming from first crystal are confined to one plane, so it is linearly polarized. So the first plane is called polarizer. The second crystal decides the nature of the light waves transmitted to the first crystal. So second crystal is called analyzer. The significance of polarization. This experiment provides that light is transverse in nature. This resultant shows that Huygens' concept was wrong. That means light waves are not longitudinal in nature. This result showed that some crystals are optically active. The best examples of polarization, tourmaline, quartz, etc. So what is the polarization of light waves? From the diagram, analyze polarized light and no light passing in the P2 crystal. When ordinary light or unpolarized light is passed through a pair of tourmaline crystal planes P1 and P2 with their planes at right angle to the direction of propagation of the light, then the intensity of the emergent light is maximum. But when the crystal plane P1, P2 is rotated to 90 degrees, the plane P2 is perpendicular to P1, then the intensity is a maximum. That means it is a maximal light. This shows that light is a transverse wave motion. It is also clear that after passing through the crystal P1, the light vibrates only in the direction. That means light is polarized because it has acquired the property of the one-sidedness. Plane polarization. When ordinary light is passed through a tourmaline crystal or rocky salt or quartz crystal, the light is polarized and the vibrations are confined only one direction, which is a perpendicular to the direction of propagation of light. So the plane of the wave propagation, the vibrations are confined only one direction, which is a perpendicular to the direction of the propagation of light. The plane which contains the direction of vibrations of the polarized light is called plane vibration. So my dear students, the plane polarization from the diagram, ordinary light and plane polarization. So the plane passing through the direction of propagation and perpendicular to the plane of vibration is known as plane polarization. This plane has no vibrations. This plane is called no vibrations. The representation of polarized and unpolarized light. Unpolarized light is from the diagram. Unpolarized light will have the vibrations along the plane of the light in the all possible directions with the same amplitude. It has vibrations both along the plane of paper and perpendicular to plane of paper. Paper and perpendicular to plane of paper, that is called unpolarized light. So plane polarization light or plane polarized light, if the vibrations are confined to a single plane, then that is called plane polarized or linearly polarized. The vibrations along the plane of paper are represented by arrows. Arrows. The vibrations perpendicular to the plane of paper is represented by dots. That is called the vibration of the perpendicular to, that is called the vibration perpendicular to plane of paper is represented by dots. That is called plane polarized light. Partially plane polarized light. Partially plane polarized light is represented by either more arrows and less dots, or more dots and less arrows. That is called plane polarized light. So here it is called either more arrows and less dots, or more dots and less arrows. This is called partially plane polarized light. Types of polarization: linear polarization, circular polarization, elliptical polarization. So what is the first one is a linear polarization. Electric field vector oscillate along straight line in a one plane. That is called linear polarization. Circular polarization is circularly polarized light consists of two perpendicular electromagnetic waves of equal amplitude and 90 degrees difference in the phase. That is called a circular polarization. And elliptically polarized, the elliptically polarized light consists of two perpendicular waves of unequal amplitude, which differ in a phase difference of 90 degrees. But the difference of circular polarization and elliptical polarization, it is electromagnetic plane wave of equal amplitude is 90 degrees, but here two perpendicular waves of unequal amplitude which differs in 90 degrees, that is called circular and elliptical polarization. So types of polarization, linear polarization diagram is as shown in the figure, circular polarization and elliptical polarization. So linear polarization is the plane polarized wave. So it is always, it passes to the sinusoidal wave, plane polarized wave. Electric field vector oscillates along a straight line in a one plane. Straight line in a one plane. So that is called linear polarization. And circular polarization is, it consists of 90 degrees equal amplitude of electromagnetic wave. So let us consider the two perpendicular plane electromagnetic waves with equal amplitude and 90 degrees phase difference. The plane of oscillation rotates around the propagation axis, may be right circularly polarized, that is called clockwise direction, or left circularly polarized, that is called anti-clockwise direction. So it is called the clockwise direction, and sometimes it is called the anti-clockwise direction. So elliptical polarization. My dear students, It consists of two perpendicular waves of unequal amplitude that differ in a phase difference 90 degrees. So this is called the wave propagation from the one place to another place. And the electromagnetic waves, it passes to the unequal amplitude that differs in the 90 degrees of the phase. The tip of the resultant electromagnetic vector describes an ellipse in any fixed plane intersecting or normal to the direction of the propagation. Circular and linear propagation, the special case of elliptical polarization. So, very important topic is Nicol prism. Nicol prism invented by William Nicol, 1828. It is a device to produce and analyze plain polarized light. So, calcium crystal whose length is 3 times that of its breadth is used. By grinding and polishing, the angle of the small faces are 68 degrees and 112 degrees. This crystal is then cut into two pieces. Then these two pieces are made optically flat by polishing and joined using the transparent material is called Canada balsam material. Canada balsam material. It is a Canada balsam is a transparent material. So Nicol prism, the refractive index of the Canada balsam is 1.55, and when the rays split into the two, one is called ordinary ray, refractive index is 1.658, and refractive index of extraordinary ray is 1.486. Ordinary ray strikes on a Canada balsam layer with an angle greater than the critical angle, and then ordinary ray undergo total internal reflection. What is the total internal reflection? The refractive index of the material, the angle of incidence is greater than critical angle, that is called total internal reflection. The reflected rays absorbed by the block film coated on the sides of the crystal. So the principle of Nicol prism, Nicol's prism is a device for producing and analyzing plain polarized light. When an ordinary light is transmitted through a calcite crystal, it splits in ordinary and extraordinary beams, which are plane polarized and are mutually perpendicular to each other. In year of 1828, Nicol established the ordinary ray by utilizing the phenomena of total internal reflection at thin film of Canada balsam separated the two pieces of calcite. This is the device is known as that is called Nicol's prism. From the diagram, the construction, a calcite crystal whose length is 3 times of width is taken. The end faces of the crystal are grounded such that the angles in the principal section become 68 degrees and 112 degrees instead of 71 degrees and 109 degrees is increase the field of view. The crystal is cut into two pieces by the plane perpendicular to the principal section as well as the end face of PR and QS. The two cut pieces are grinded and polished optically flat and cemented together by Canada balsam. The refractive index of Canada balsam lies between the refractive index for ordinary and extraordinary rays of the calcite crystal. So the refractive index of ordinary crystal is mu naught is equal to 1.68, and extraordinary Canada balsam refractive index is 1.55, and extraordinary ray is 1.48. So this is called the construction of Nicol prism. Some of the limitations of Nicol prism: if the incident beam makes an angle much smaller than the ordinary ray will be striking the calcite
calcite balsam layer at an angle less than critical angle 69 degrees, the both ordinary and extraordinary rays are transmitted the prism. The uses of Nicol prism. The Nicol's prism can be used both to polarizer and analyzer. So that is called a very important uses in Nicol prism. So wave plates, the wave plate is doubly reflecting crystal, then it is the form of plate which its optic axis along the surface. Generally, we have two types of wave plates, quarter wave plate and half wave plate. Quarter wave plate, my dear students, let us consider a colloidal crystal cut with the optic axis parallel to the surface. When the plane polarized light falls normally on a thin plate of unaxial axis, that is called calcite crystal, cut parallel to its optic axis, light splits up into ordinary and extraordinary plane polarized lights. Then they travel along the same path but with different velocities. The velocities of extraordinary ray is greater than the velocity of ordinary ray. If the thickness of the crystal plate such that it introduces a phase difference of pi by 2 radians and path difference of lambda by 4, then it is called quarter wave plate. To calculate the thickness of the plate, we produce as follows. Let T is called thickness required for such plates be the refractive indices of the crystal. If the mu naught and mu is ordinary refractive index and extraordinary refractive index for the waves, then the path difference is mu naught minus mu v into T is equal lambda by 4. If mu naught greater than mu v, T is equal lambda by 4 into mu naught minus mu e. Mu naught minus mu e, that is called quarter wave plate. Another one is half wave plate. Let us consider a calcite crystal cut with optic axis parallel to the surface. If the thickness of the crystal plate is such that it introduces the phase difference is pi and path difference is lambda by 2, it is called quarter wave plate. When the light polarized, the plane polarized light falls on normally on the plane plate, unaxial crystal cut a parallel to the optic axis, light splits into the ordinary ray and extraordinary ray polarized lights. They travel along same path but in the different velocities. The velocity of extraordinary ray is greater than velocity of ordinary ray. To calculate the thickness of the plate, that T is the thickness required to such a plate be the refractive indices of the crystal. If ordinary refractive index and extraordinary refractive index of the waves, then the path difference between mu naught minus mu v into T, then mu naught greater than mu v. So therefore T is equal to lambda by 2 into mu naught minus mu v. That is called half wave plate. So examples of some of the applications of polarizations. Polarization is used to differentiate longitudinal and transverse waves. Polarization used in glare reducing sunglasses. Polarization is used to produce and show 3D movies. Polarization is used in IR spectroscopy. Polarization is used in the measurement of photoelasticity. Polarization of cosmic microwave background is used to study physics of early university or universe. So different longitudinal and transverse vibrations. So transverse is called perpendicular, longitudinal is parallel to the wave propagation. Applications of polarized light is a non-polarized and polarized light. Glare reducing sunglasses, 3D movies using the polarization, IR spectroscopy, measurement of photoelasticity, physics of early universe. Thank you.